Hey there, Math 1. I've got a new video for you. We're still talking about writing linear equations given 2 points, but these are kind of special cases that require us to think a little bit outside the box at times. On other times, you don't need to really think too much outside the box. Let's see what we got here. So number 1, you've got the points -7, -9, and 14, -9. So the way we know the procedure is that you're trying to write the equation using the format y equals mx plus b, right? And the idea is, step 1, if you find the slope, step 2, if you pick an x and a y and you know the m, then by step 3, you're able to actually rewrite this equation with a numerical m and a numerical b. There's numbers in place of the m and the b. So let's get to it. You've got x1, x2 for our left coordinates, y1, y2 for our right coordinates. Remember, x left, y right. The slope formula never changes. It's always y2 minus y1 over x2 minus x1. So we're taking -9 minus -9 on top. On the bottom, 14 minus -7. So this is interesting. On the top, anything minus itself is 0, right? The minus minus creates a plus. -9 plus 9 is equal to 0. The minus minus down here also creates a plus. It's 21 on the bottom. Now here's the question a lot of you guys have. What is 0 divided by 21? Well, you can think about it maybe using like a real life example. Let's say I have $0 in my pocket, and I'm dividing that $0 amongst 21 people. All right? This is just me providing context to the fraction. 0 over 21, how much does each person get if it's $0 divided amongst 21 people? $0 per person. And that makes sense, right? If I have no money and I'm dividing it amongst a bunch of people, they get no money. So, what is 0 divided by 21? It's 0. Interesting. Okay, so my slope is m equals 0 for step 1. So that means m is going to equal 0 when I do my plug-in. Picking x and y, remember, I can either pick 14 for my x, -9 for my y, or I can pick -7 for my x and -9 for my y. I'm just going to go with 14, -9. One of them's positive. Maybe that'll be helpful. So what I'm doing now is I'm taking those 3 values and I'm plugging them into this format. Instead of a y, I'm going to plug in -9. Equals, instead of the m, I'm going to put 0. Times, instead of the x, I'm going to put 14. And then plus b. So here's the equation I'm solving for b. -9 equals, anything times 0 is going to be 0. Right? Multiplicative property of 0, chapter 1. And anything plus 0 is itself. Remember, that's the additive identity? Ooh, you guys are probably having flashbacks. You don't want me to mention those things. All right, so I've got my b is -9. My m is 0. Step 3, we are literally rewriting y equals mx plus b, except instead of an m, I'm putting a 0. Instead of the b, I'm putting a -9. So this is one way to express your final answer. However, think about this. 0 times anything is 0, okay? So this is the same thing as y equals 0 minus 9. And what's 0 minus 9? It's -9. So I guess the formal way of doing this, the more recommended way that people read something like this, is they would just say it's y equals -9 because the 0x zeroes it out. So this is kind of a special case because it doesn't necessarily look like this pattern when you simplify things out. Y equals -9 would be our final answer for this one. All right, let's move on to number 2. Oh, by the way, no, wait, hold on. Moving on to number 2. So we're still given 2 ordered pairs, 2 points on the graph that we're trying to write the equation of. Here's x1, x2, y1, y2. We're still trying to make it fit the format y equals mx plus b. Still worked last time, even though last time was a special case. So we'll try again with this one. And the slope formula is y2 minus y1 over x2 minus x1. Plugging things in, m is equal to 7 minus -3 over 8 minus 8. So the minus creates a plus. It's going to be 10 over 8. No. 8 minus 8 is 0. Ooh, that just doesn't look right. So we've got to ask ourselves the question, what's 10 divided by 0? Well, again, let's use the context that I had beforehand, right? I said, hey, what if you've got $10 divided amongst 0 people? How many dollars per person would that be? Well, the weird thing about trying to divide by 0 is that, remember, division is the reverse of multiplication, right? You're asking yourself, 0 times what gives me 10? That's the same thing as asking what's 10 divided by 0. The question mark is the quotient. It's the answer to either one. And the idea here is, if I multiply anything times 0, I get 0. So there's no solution to this question mark right here. There's no number that when you multiply by 0, you get 10. So this right here is kind of gibberish, right? I have $10 divided by 0 people. How many do each person get? How much does each person get? There's no people to talk about. So that ratio is sort of an undefined number. It's a value that doesn't really exist anywhere. So this is the really weird, tricky thing that happens. In this particular situation, you have to say that 10 divided by 0 is going to be an undefined value. Okay, so if you recall, if you think back to the special case graphing, what kind of graphs had undefined slopes? And, I'm not going to go through and explain that whole procedure again. I already made a video on it. Go back and watch that video. Special cases graphing. I think it's 5.3 or 5.4. Vertical lines. Vertical lines had undefined slopes. So what kind of equations do vertical lines have? And it's a truly extra special case. If you watch that video again, you'll see that x equals a constant is the equation for the vertical line. And the constant in question is the place where it crosses the x-axis. So that constant right there is the x-intercept. And how can we determine that by just the 2 points that we were given? Every point on a vertical line has the same x value. So you see the two 8's right there? 8, 8. X equals 8. X1 equals 8. X2 equals 8. X3 equals 8. X negative 50,000 equals 8. So the equation of our line is x equals 8. So what we're learning from this particular example is that vertical and horizontal lines completely blow up the y equals mx plus b paradigm. The y equals mx plus b format doesn't really establish itself well for these special cases. So to clarify this, or maybe the better word would be summarize it, can we just come up with a strategy for if we see a special case occur, can we just avoid the whole process of trying to go through y equals mx plus b? Well, look at example A right here. Both x's are 3. You know what the equation of this line is? X equals 3. It's a vertical line with an undefined slope. I'm done. That's the equation of the line that passes through these 2 points. If both x's are the same value, it's a vertical line. If both x's are the same value, as you see in part A, then it's a vertical line whose equation is x equals that same value. Got it. Okay. Great. As long as I can just commit that to memory, not just up here, but down here as well. Like, we really understand what's going on here. Then what we can do for part B is say, are both x's the same? No, one's 7, one's 3. But both y's are the same. Both y's are 7. Y equals 7. Y always equals 7. Yes, okay. So, if both y's are the same value. By the way, I didn't say this in the first example because I didn't want us to get off track, but this means that it's not a vertical line, but it is a horizontal line. You know, horizontal, whoosh, whose equation is always y equals some constant. Okay, so that's a quick way for you guys to avoid any headaches when you're like, I found the slope and it's weird. It's either includes a 0 or it's dividing by 0, and that just does not jive well with fluid homework assignments. So committing this to memory and really making sense of it is kind of essential for really understanding linear equations. All right, and then the last one. What I wanted to show you guys is that sometimes we get kind of caught up. Once we learn about special cases, then we think everything's a special case. If you look at part C, x is negative 1 here, but x is positive 1 here. Y is negative 2 here, but y is positive 2 there. They're not the same. So it's not a vertical line, and it's not a horizontal line. Well, then what is it? y2 minus y1 over x2 minus x1. This is going to be 4 over negative 2. Oh, it's just a normal linear equation where you find m, you pick an x and a y. It doesn't really matter in this situation. I'm going to pick x equals 1 and negative 2 for y. M is negative 2. Plug it into y equals mx plus b. So the y is negative 2, the m is negative 2, the x is 1, the b, we're just waiting for it. Negative 2 times 1 is negative 2 plus b. Add 2 to both sides. Okay, that zeroes out the left-hand side. Oh, our starting point is b equals 0. And that's kind of a special case. But it's not a special case that can just be identified like that as, oh, it's a vertical or horizontal line. This is perfectly acceptable to call this y equals negative 2x plus 0, which is the same as y equals negative 2x. All right, so that is neither a horizontal nor a vertical line. You might want to write that in your notes, maybe up here. Neither horizontal nor vertical. All right, so this lesson's going to be a lot more of me explaining on this video. We're almost 17 minutes in it, and I've only gone through page 1. Second page is more calculation driven, so it's not going to be a lot of weird new concepts. It's just going to be, how do we deal with decimals, and how do we deal with fractions when they show up in our coordinates? All right, thanks for watching. Part 2 coming up.